Hi there. So 9.3 trig functions of any angles. This is pretty important up here. It tells me that the sine of any angle is y over the radius. See, the radius is going from the center of the circle to the point on the circle. Your cosine is x over r, and your tangent is y over x. And of course, we can never divide by 0. And the radius is never going to be 0. So currently, here we have a situation where we have a point -4, 3 on a terminal side of an angle in standard position. So right here is that point. I go over -4 and I go up 3. This is on a circle, and so I can calculate the radius by knowing -4 squared plus 3 squared is going to equal my radius squared. So my radius on here, or my hypotenuse, is 5. I now just follow this. Y over r is my sine. So my y value is 3, my radius is 5, so my sine of that angle is 3/5. My cosine is the x value, which is -4, over the radius, which is 5, so -4/5. My tangent is -3/4. So notice I write the negative on the numerator, or you can write it in front of there. The other three trig functions are the reciprocal of that. It's a little different if I am using the unit circle, which we have already done. We have filled out that unit circle in the front of the booklet. We did that in the third quarter. So here it says use the unit circle. So it's not a point on the circle. I'm using a unit circle where I know the radius is 1. And on the unit circle, they give me 270 degrees. So I remember my unit circle, 270 degrees, as an xy point at 0, -1. So this is my x value, this is my y value, and my radius is 1. I use those same little formulas up here. The sine is going to be y over radius, and that simplifies to -1. My cosine is x over radius, and that simplifies to 0. My tangent is y over x, and that's undefined. Then I have the reciprocal trig functions for all three of those. So let's use this information on the next three problems on page 12. So evaluate the 6 trig functions of theta. Here I am given a point 3, -3. I first calculate my radius to be 3√2. Now I have to remember that radical cannot be in the denominator. So my sine is my y value over my radius, and that simplifies to -√2 over 2. My cosine is √2 over 2. My tangent is -3 over 3, which is -1. Then the reciprocal on all of these are shown here. Now this one's not quite as bad because we don't have to deal with a radical, but I have the x value, -8, the y value, 15. I calculate, that's the first thing I do, is calculate the radius. So the radius is 17. My sine is y over radius. My cosine is x over radius. And my tangent is the y value over x. And that's a negative on that one. Now, we have cosine and then sine, alphabetical, and x and y, alphabetical. So that helps me remember that the cosine is always the x value. So the -8 over the radius. Here I have two negatives, so I'm down in the third quadrant. Sine is going to be y over my radius, which I calculated to be 13. Cosine is going to be the x value over the radius. And my tangent is going to be a -12 over -5, which simplifies to +12 over +5. Flip all of these to find the reciprocal.